Welcome. I'm pleased to welcome you to the second webinar of the 2025 series. My name is Rob Bertels. I'm an instructor at the Water and Wastewater Technology program at TRU. I also work with a team of experts on the Online Help Center for BC Small Water Systems. Before we begin, I'd like to acknowledge that the Thompson Rivers University campuses are on the traditional lands of the Tk'emlúps te Secwepemc, which is Kamloops campus, and the Tulk, which is the Williams Lake campus, within the Secwepemc Kuluk, the traditional and unceded territories of the Secwepemc. Just a little bit of background here. Thompson Rivers University, with their partners, host an annual webinar series and courses dedicated to providing technical information, resources and tools for small water system owners and operators and Indigenous small water systems on issues around treatment, regulation, operations, maintenance, and water quality monitoring. The Online Help Center strives to assist all small water systems in BC to implement a multivariate approach to safe drinking water, so water systems can provide consistently safe tap water to their communities. These free webinars are scheduled every 2 months in 2025 for attendees who are EOCP certified operators. Each webinar will count as 0.1 CEUs towards your certification. A certificate of completion will be issued to the webinar participants, which they can then submit to the EOCP for your records. We will have a 1-hour presentation first, followed by half an hour of question period. During the presentation, if you have any questions, please jot them down in the question section and we will make sure to address those questions after the presentation. So the webinar today is going to focus on distribution system flushing for small water systems. In the webinar, we will be addressing methods and operations for distribution system flushing and the proper equipment required for effective flushing. The following topics will be covered: important components of a flushing program, methods of flushing, equipment required, procedures to maintain flow velocity, parameters for measuring effective flushing, turbidity, chlorine, residual pH, and total dissolved solids. Scott Jameson is our presenter today, and Scott is a graduate of the OUC in 1996 with a diploma in water engineering technology. He holds a level 4 certification in small water system treatment, distribution, and wastewater treatment. Scott runs Jameson Water Services training, Jameson Water Services training, and he's out of Victoria, BC. He provides hands-on consulting services in the operations and maintenance of water, wastewater systems. He also teaches at Thompson Rivers University in the Open Learning Certificate in Water Treatment Operations program. And just a note before I hand over the screen to Scott here, Scott has provided some handouts for you to use. They're provided in the webinar, but they are also provided on the Online Help Center website if you just check where you can find webinars. And so with that, I'm going to turn the screen over to Scott, and Scott, you can begin your presentation once we've done that.
Perfect. Thank you, Rob. Thank you for the good introduction. And I will try to get right into here. We've got a lot to go over. So I just want to make sure we have a good chance of getting it all. I'm going to share a presentation here, and then I'll go through the handouts that that Rob had mentioned. So as we said, we're going to go look at some water system flushing and some details on it, whether the equipment, how we're going to do the flushing, measuring the effectiveness of that flushing. And once again, any questions, please put them in the question section, and we'll try to get to those at the end. Now, one of the key things of why this is very, very important as far as the operation of your small water system is, the American Water Works Association, they have a nice blanket statement here, where water main flushing is the best maintenance procedure to maintain water quality in a distribution system. So the idea is if you don't do anything else on your system, you should at least flush it once a year to try to maintain that water quality. And what we're trying to do here was we're making sure that there's fresh water throughout our entire system. We're trying to remove any debris or biofilm that has built up in the piping, in reservoirs. So those are all things that we are trying to achieve. Now, in the process of this also gets you out in the field, finding valves, locating other issues or problems with your distribution system. And some of you may just do flushing on a regular basis to help maintain that chlorine residual, and helping to reduce those taste and odor complaints that you might be getting from consumers on your water systems. So once again, this is what we're trying to achieve. Now, what we're looking at here is just an example of what we're trying to achieve within the pipe here. So the very top diagram, this is what normally happens in your distribution system in the pipes, right? People are using the water, they're flushing their toilets, taking a shower. We get what we call low-speed laminar flow, and it really travels down the center of the pipe because that is the area of least friction, so the least resistance to the flow of that water. So that means that if there is any debris or anything that is in your water that's made it into the pipe, if it can get out of that very center of the pipe, well, then there's nothing to disturb it. So now it can settle down at the bottom of the pipe. We move to the middle diagram there. That one's what we call a medium speed. So maybe there's lots of people all showering at the same time. We're getting a little bit more turbulence. We're kind of getting a little bit of a wave down the center of the pipe. And, you might see this at times where, hey, lots of people are using water and it maybe picks up a little color, maybe a little bit of debris. But that's also not what we're right where we're at. What we're trying to do by doing a dedicated dedicated distribution system flushing is we're trying to achieve the bottom picture there, where we are going to increase the velocity of the water in the pipe so much that now we're going to create huge turbulence within that pipe. And so we're going to get waves that are going to be bouncing off the top of the pipe and the bottom of the pipe and the sides, and they're just going to be picking up anything that's there. They're going to get a chance, if we get high enough, to maybe tear off any biofilm that might be growing on the pipe, and hopefully carrying that out to our discharge point, right? So that's really our objective, is to create as much turbulence as possible within the pipes in our distribution system so that we can pick up and discharge that debris that is accumulated over the year. So now that said, if we're doing flushing, we can do this, whether it might be just regular flushing of our dead end lines in our distribution system. We do it as part of our hydrant maintenance program, or we can look at, hey, are we going to do this as a dedicated procedure on its own? The last two there, those ones are getting more advanced. We'll kind of touch on those real quickly, but it's a little bit beyond the scope of what we can cover in the hour. Now, each one of these different types of flushing we're doing, they all have advantages and disadvantages, but no matter what type of flushing we're going to do, before we get out there, we really need to establish, what are our goals and objectives of this flushing, and how are we going to measure, did we achieve those goals and objectives? And so I'm going to go over what some of those goals and objectives should be. So before we go, these are some of the questions we might want to ask, that will direct us to, hey, what are our goals and objectives, and how are we going to measure that, right? So why are we going out there to flush, right? Is it just to, I've got a dead end main and I don't have chlorine residual out here, I just need to flush to get chlorine residual? Is it, well, it's our annual flushing time, I want to remove as much debris and biofilm as possible, right? Those ones are going to direct you to different procedures. Where are you going to flush? So what hydrants, what blow-offs, what areas are you going to flush from? A big one is how long, right? Are we just going to go out there and turn on a fire hydrant and then, you know, check our messages and look around for some birds for a little while and then decide, okay, well, that must be good enough? Or are we going to try to use some measurement to really tell us, hey, how long should we be flushing, and is that going to be adequate? Now, the big ones, you know, are we going to how are we going to measure that effectiveness, right? How did our flushing actually achieve our goal? And with anything, we need to also look at our record keeping, right? Are we keeping good records so that we can look back at this after we're done, or look back at it as the previous year and say, you know, this is what we did last year and this didn't really work, we didn't meet our objectives. You know, do we need to change this year? Or, you know, has there been a change in the system, or you know, something we should be doing a little bit different to make our flushing more effective? So, as I said, first big question, why are you going to flush, right? Because someone told you to, or, you know, do you have, you know, that's not the best one. You need to try to look and say, you know, what is my actual goal here, right? Why am I out here standing at this blow off? Why am I standing at this hydrant and I'm going to discharge water out of here, right? You know, once again, is it just for chlorine residual? Is that what I'm looking for? Has there been an odor complaint or a taste complaint to the water? Or in our system, you know, are we there to remove debris from the system? Is that what we're trying to achieve? So knowing, you know, why you're there really helps direct you to answering some other questions about the effectiveness or how you are going to do that flushing. Now, where are you going to flush is the next big one, right? You know, if you need to increase chlorine residual on a section of the distribution system, obviously you want to, you know, hopefully go to the end of that section and flush all the way out at the end there. Is it because you've just done a repair and so now you're going to flush downstream of that repair? You know, where's a complaint in your system? Are you going to flush nearby where that complaint occurred? One of the big key things, though, is you do need to go check out the area, you know, where you're going to flush, because sometimes what looks on the map or in your head, the most convenient place to flush is not the most effective and might have some limitations. You know, maybe that hydrant that's the end of your system is, you know, right by someone's driveway, and there's not good drainage for doing a flush there. And so maybe we need to look at flushing somewhere else instead and alter our program. Now, this is always the big one, is how long are you going to flush? So, and by once again looking back to our question of why we are there, well, you know, if all we're doing is we're trying to release entrapped air after a repair, well, then we're just going to, you know, flush until we don't hear air coming out anymore, right? And that should be good enough. You know, are we just testing the operation of a fire hydrant? That can be very, very quick. Now, we also, again, we need to look at some of the limitations of our system when we're looking at how long we're going to flush. So, you know, are we in a sensitive area? You know, not good drainage. There's a fish-bearing stream right next to us that we need to be aware of, and so we don't want to flush in that area or flush for long in that area without doing proper dechlorination. And then are we doing some other types of measurements that are allowing us to determine how long are we going to flush for? And so we'll go through some of these ideas on determining how long that is. And the next question, you know, how are we going to measure the effectiveness of that flushing procedure? Now, what we want to do is we want to move from things that are subjective to things that are objective. So we want to move from things that are just observations to things that we can actually measure. So, what we don't want to do is we don't want to be flushing a blow off or a hydrant and just be looking at the water and saying, well, I think it looks clear now, we must be good. I took a sample of it and it doesn't seem to smell bad anymore. It doesn't taste bad to me. Those are all subjective observations. What we would like to do is move into things where, what are we measuring, right? We're using instruments to help us collect some actual data. And it could be very easily as, hey, the chlorine residual, there was no chlorine residual when I started flushing. Now the chlorine residual is 0.4 milligrams per liter, or whatever my target was. Perfect. I have flushed for long enough. Or my turbidity it's gone down below 1, so my flushing must be complete. We can also look at calculating out our flushing flow rates and timing the flushing if we have the right equipment, and we'll look at some of that equipment here shortly. And record keeping is important for everything. We need to really know, where did we flush from? How long did we flush? Did we use dechlorinator, right? Especially if you are in a sensitive area, you're near a fish-bearing stream or water body. Any other data, right? After a minute, the water turned really brown. I observed this while it was flushing. There seemed to be rocks coming out. Whatever it happens to be is, we need to make a record of that. Also, the data that you collect while you are doing. This was the chlorine residual when I started. This was the turbidity when I started. This was the turbidity, chlorine, pH when I finished. Whatever it is that you are measuring, we need to make good records of that. And then this is more of an end analysis of our flushing after we're all done. We can look at and see, okay, is there something else that I could be doing? And this might be moving to a more aggressive flushing procedure, like a unidirectional flush. Maybe it's doing things like a swab, or putting in other infrastructure, maybe an auto flusher to help us with this dead end main or dead end section of our system that we're always constantly having to go out there and flush to maintain chlorine residual. So once again, that's more of an end analysis after, when we're looking at all the records that we have made while we're out there doing flushing. And one of the key things, though, is when we're looking at flushing of our systems, this is a very dynamic process within our water systems. This is not something that we wrote up a procedure once, and we just follow the same procedure every year, right? We need to keep this cycle going around and around, where if we start up at the top there with the planning, right? It's okay, we have a plan. This is how we're going to do flushing this year. We got all the right equipment to do the flushing that we want to do. We've notified the public of the flushing. We went out, we did the flushing, we looked at all our data, we really evaluated then, okay, this was our goal, this is what we did, this is what we achieved. Did they all align? And if they didn't align, well, go back to the plan, right? Okay, well, let's rewrite the plan, and next year or the next time we do flushing, we'll try the new plan. And maybe the new plan doesn't work, and you go through the cycle again then, right? Try a different plan. And for some systems, maybe you're simple enough, easy enough that you have the perfect plan that works for your system. Doesn't mean, though, you should not review it every year, right? Look at the data you collected while you're out in the field, and look at the plan. Right? Is this really effective for your system? System administration, we do need someone to look over the entire system, make sure that when we're going to do the flushing, that cycle goes all the way to completion. And it's nice to, maybe you have other people helping out in certain aspects, but there should be one person who is making sure that, just to go back, that this cycle goes all the way around and we complete all the steps of the flushing program. So, and for most of you, I'm going to assume in your small systems, it's going to be one person who's looking after everything, and that's also the same person who is out there doing the flushing out in the system. Right? But if you don't, you need to make sure everyone is on the same page of what is happening in the flushing program. So planning, if we start out at that first step, we want to look at maps of the water system. We want to try to make out a written plan and procedure for what we are going to do out in the field. And once again, then we can review that when we are done. By doing that written plan also, that should help direct us to, do we have the proper equipment to do the flushing, and what type of notification are we giving out to people for doing the flushing. So maps, we need to be able to find our locator maps and try to use those to plan out the flushing system. I mean, once again, when we do this on the desktop, we can, when we're out in the field, we might like, hey, this hydrant here this would be perfect flushing location, except for there's not really good drainage around here, or there's some other issue or problem with using that as a flushing point, and we might have to change the plan. So once again, having our system maps helps us do that planning. And with that, having that written flushing plan, and it just does not need to be very complicated. It can be very, very simple direction of, hey, we're going to go to hydrant number 1. This is how long we're going to flush. This is the equipment that we need to go flush at this hydrant. This is where we're going to discharge. This is how we're going to dechlorinate the flow coming out of that hydrant. And this is the data we should be collecting. And I'm going to give you some examples and some of the handouts. They kind of show these plans, how we're going to maybe write these flushing plans out. Equipment. So, we can run through a list, and we need to make sure we gather all this before we head out into the field, right? We're going to need valve keys. We're going to need hydrant wrenches, right? So whether it's a blow off we're using or a hydrant we're using for discharge. Do we need hoses, right? Are we going to have to direct the flow out of that hydrant across the street and into a drainage ditch? So what length of hoses do we need? We should have some sort of diffusers, right? We need to diffuse the energy of the water coming out of our blow off or out of our hydrant, so that we're not creating property damage in the surrounding area. Do we have dechlorination equipment? So, does that part of our diffuser, or is that some extra equipment that we are going to use for doing dechlorination? Now, the other things like pressure gauges, the flow gauges, one thing I don't have listed on there is our testing equipment. These are other extras that are highly recommended that you have and use as a way to measure the effectiveness of your flushing program. And then we have to do our signage and safety equipment. So, do we have enough cones to delineate off our workspace? Do we have signage that we can put out in the streets for people for traffic control, but also just for notification of what we are doing? And then ourselves, do we have our VisiVest? Do we have our steel-toed boots for being out? Hard hats or gloves, making sure that we're having our own PPE so that we can do this safely for ourselves also. Hose ramps, right? If you are going to be running hoses across roadways, you do need to protect those hoses. You should not be allowing people to just drive over hoses while they are flushing. It does create a back pressure wave in your system while that is happening. So if you cannot block off the road for the time that you are doing the flushing, you can order actual hose ramps. Maybe your local fire hall has some that you can use that they aren't using anymore. And 2x4s, 2x6s, they make great little protections for any type of hoses that you are running across the street. Diffusers, this is one of the most important pieces of equipment that you are going to be using. Once again, these are devices that are going to diffuse the energy of the water coming out of the hydrant or the blow off, and so we're not getting any damage to property around where we are doing the flushing. And if we can, we can incorporate other equipment into our diffusers. So, the picture up on the top, this is a diffuser that does not have dechlorinating capabilities. So if you have a diffuser like this, you're going to have to use something else for your dechlorination. Whereas the picture on the bottom, it does have a basket inside of it so that you can put dechlorinating chemical in that basket, and you can dechlorinate as you are discharging from the diffuser. And also the one on the top is showing that this one has a inbuilt pitot that can measure the flow of the water going past that point, which is really good information as far as our planning of the flushing procedure. Right? So once again, there's all different companies that do this, whether you have the Polar Water ones or Hose Monster, whatever it is you're using. Try to see if you can get ones that can incorporate in multiple uses, right? Whether you're measuring flow or dechlorinating right with your diffuser. No matter which type of diffuser you use, make sure it is secure, right? You are going to be expelling large volumes of water. There's going to be lots of energy being expelled from that blow off or from that hydrant. You want to make sure that these are secure, and this picture at the bottom with this diffuser just kind of sitting out on the road on its own, we can make little contraptions where you can have a little side pedal off here. You can put your truck tire on there to hold it in place. They make them with a hitch mount, because what you don't want is, when you open that hydrant up full blast, is that thing to start swinging around out in the roadway. So you need to make sure that they are secure. So these are some other examples of different types of diffusers, right? You've got the picture up the top where, the diffuser is on a hitch. So we've got a hitch mount there. You get a picture on the bottom, this utility, they got very creative. They just used the top end of an old hydrant and mounted that on a hitch, and they use that as their diffuser, right? Doesn't really matter what you're going to use, just make sure that it is secure in some way before you open that hydrant up all the way. Dechlorination equipment, so quite often built in as part of your diffuser, and just understand how the equipment works for you. And you can test it after. You can look at the chlorine residual of the water coming out of the end of the diffuser, and just make sure that there is no chlorine residual being measured there. There's all kinds of different chemicals that you can use. The sodium thiosulfate, bisulfate, very common. Maybe moving up to the sorbic acid. Those are the VIT-C dechlorination tablets that you might be using. This one here, picture on the end, it's on the right-hand side. This is a dechlorination mat. So where you can just put the tablets, and then you can just put that mat in the ditch or in the roadway, and then your water that you are diffusing out of your system can run over that, dissolve some of those dechlorination pucks, and be dechlorinated. If you don't want to buy the mat, you can use a sandbag, and you can fill that up with dechlorination pucks and use that instead. That said, if you can buy one of the dechlorinators, the diffusers that have dechlorinating equipment built into it, it does make the whole process a lot simpler. Right? And once again, there's just a lot of different chemicals that we can use. This picture here, the dechlor, whether it's the sulfite, bisulfate, thiosulfate, or ascorbic acid, those all four of those are very, very common. They do have this ratio of how much of that chemical it takes to dechlorinate the water. And I'm just going to go back. That is more on this dechlorinating device here that is on the left. As dechlor is reasonably expensive. So if we happen to be using lots of it, we can maybe dial in the use of it a little bit more and just use the exact amount that we need to dechlorinate the water. That's getting a little bit more advanced than probably most of you need. Once again, just dissolving the pucks should be good enough. Pressure and flow gauges, also a great instrument to have while you're out there doing flushing. So you want to be able to look at what the pressure is on the blow off or the hydrant that you are using. We can use these pressures, what is the static pressure before we flushed, but we can also measure the pressure that is being generated while we are flushing. So that is also good information to have. And we can also maybe look at, can we put a pressure gauge somewhere else in the system and see what the pressure change is while we are doing our flushing inside of our system. And what we're looking for here is, while you're doing your flushing, we need to try to maintain at least 20 PSI at all points inside of our distribution system. So if you have a concern, let's say you're at the bottom of a hill and you're like, well, I'm going to turn on this hydrant at the bottom of the hill and flush from it because it's the end of the line, it's the perfect spot, but I'm worried that at the top of the hill, I'm going to lose pressure up there while this is happening. Then you can take your pressure gauge and put it on a home up at the top of the hill or a hydrant, and while you're doing your flushing, go back up there, read the pressure, or have someone who's helping you read the pressure and see, okay, am I able to maintain 20 PSI somewhere else in my system while I'm doing that flushing? So that 20 PSI is very critical. Once we go below 20 PSI, we are in danger of doing back siphonage. So we're creating a concern of cross-contamination in our system. So if we do note that, then that's something we put in our records. And once again, we can go back to that plan and say, look, this was my original plan, but this created a problem for me. I need to adjust my plan here. Signage and safety equipment. I know this picture, it's the city of Victoria. It's a large city, but we can have the same thing, right? Some cones, put out a sign, allow people and let them know, that we're doing flushing out on the system. This is what's happening, and help them direct any vehicles around where we're doing our flushing. So just some other ideas, right? Doesn't need to be anything big and fancy. The one up on the right, their notice, right? It's just a little lawn notice that they can put out there. And this might just be also, while you're out flushing, residents want to know, right? Hey, how come we're on, it seems like you're wasting a lot of the water in our system. What's going on here? So we want to let them know give them some information of why we're out there flushing the system. And that leads into here, the public notification. And what should that notification include? Well, we want to give as much information as we can. We'll go over this. There's a couple of the handouts that give very, very detailed information on this that you can use to write your own notification. So you've got some resources for helping you there. But we want to cover, when are we going to be flushing, but really why are we doing it, and what the customer might have to do. So whether that's, hey, while we're doing the flushing, your water might turn brown, or you might lose pressure, or there's going to be, you might get air pockets coming through your service line. We also always want to have a contact number. So if someone has questions or concerns, that they know where to send those questions or concerns. And for most small water systems, it's pretty easy to get the notice out to everyone, but you have to have that. What is the plan, right? Are we just going to post a notice in the community newsletter? Are we doing a Facebook post? Are we putting a sign up at the mailboxes? Are we just going door to door and handing someone a sheet with all the information, right? How is that that information getting out to people? And once again, there's a little example of, you might see these in your local newsletter or whatever. But just real quick, and what's the key part, we want to let people know what to expect, but also who to ask more questions of. So we've got our plan, we've got all our equipment together, we've sent out notification to people. Now we go out and actually do the flushing. Right? So while we're doing the flushing, we need to collect data, right? What was the chlorine residual before I flushed? What was it after? What was the turbidity before? What was the turbidity after? What type of flow did I get? And by looking at that data, that's going to allow us to do that evaluation of how effective our flushing was. So looking a little bit more in depth now on some of the different types of flushing we might do. The first one we categorize as a dedicated flushing procedure. And when we're trying to do a dedicated flushing procedure, our goal is to move clean fresh water from our source through the treatment process all the way to the ends of the line. So we need that plan in place. We need to flush each hydrant or blow off in a set order throughout the entire system. While we're planning this out though, one of the key things we want to do if our system has different sized mains is we want to flush all the large mains first. So if we got 6-8 inch mains in our small water system, we want to do those first. Then we're going to go back and do the smaller, right? We have some 4 inch, some 2 inch that is in our system. Okay, we're going to go back and do those ones after we get the large pipes first. So these ones are pretty easy. If you've got this kind of system that is on the left there, we call that a tree system. And that is where, you've got the lines just go in one direction, they end in dead ends. There's very little looping or no looping at all. Well, that one you can just go, it's very easy to go, okay, this is my source. I'm going to go out to the very end. If your system is looped, a dedicated flushing procedure may or may not be effective for you, depending on how you do that. And we're going to look at those loop systems a little bit more in detail here shortly. Now, for doing a dedicated flushing procedure, the AWWA best practice is that your minimum flushing time must be the amount of time it takes to exchange 2 volumes of water in that pipe. So we're talking about where was the last point that you flushed from and where are you flushing from now? What is the volume of water in the pipe between those two spots. And now we're going to double that, and we're going to exchange that volume in the pipe twice. And that's going to be the minimum time. Now, our actual times might be longer than that, but what we're going to try to look for that minimum time is that's when we should really start our testing. So, for example, if we have looked at a section of pipe and we have determined, there's 5,000 liters of water in this section of pipe between hydrant number 1 and hydrant number 2. And when I'm flushing hydrant number 2, I'm doing 1,000 liters a minute. So it's going to take me 5 minutes to flush one volume. I need to double that. And now my flushing is going to take 10 minutes. At that point, then what we're going to do is we're going to flush for that minimum amount of time. We're going to wait, sit there with our timer, wait that 10 minutes. And then at that 10-minute mark, that's when we're going to start testing the water, right? And if after 10 minutes, my chlorine residual is where I want it to be, my turbidity target is where I want it to be, perfect, right? I have achieved best practices flushing. I have done 2 volumes of water. I have moved clean, fresh water to my second point there. I'm done, right? Shut it down, make my records, move on with the plan. Conversely, I might be, okay, I've let it go 10 minutes. That's my 2 pipe volumes. And you know what? I still don't have good chlorine residual. My turbidity is still too high. My pH isn't where I want it to be. Well, now I'm going to continue that flushing. And now it's up to you to decide what that time is going to be, right? Am I going to retest every minute? That would be my recommendation that you do, but you need to find out then how long does it actually take for you to reach your goals. There is always limitations on this. Once again, what is your drainage like, but also, what is your capacity of your water system? And that's looking at your reservoir volume, right? So you might have like, hey, I've been flushing for 15 minutes and I'm getting a low reservoir alarm. I need to shut this down, but I'm still not getting good chlorine residual. My turbidity is still not where I want it to be, but I just don't have the water anymore to continue this flush. Again, that's good record keeping to make. Shut down your flush, go back to your plan. Try to bring in other people. Talk to your drinking water officer, any engineers that you have working on the system. Reach out to the small water users group here on the website, and try to ask, hey, this is my problem. What can I look at here to maybe do this more effectively? Now, for calculating that flushing time, like I said, we need 2 pieces of information. We need to know what is the pipe volume between your flushing points, but we also need to know, what is the volume that you are flushing out of the flow that you are getting out of your flushing point, right? Out of that blow off or out of that hydrant. Now, if you've never done this before, then the first time you go out, you're going to have to do some quick calculating out in the field. But this is where we need those flow meters that might be part of your diffuser there. So if we can measure that and have that pipe volume, we can calculate out what those minimum flushing times are. So don't worry, we're not going to do any math here. I'm just going to run through this real quick, and then I'm actually going to skip by this part of it. I'll show you a website later. I do this in class. If we were doing this in person, we would actually go through the calculation. But use a website, use an app. All you can do is put in the pipe volume. Put in the pipe length and the pipe size. It'll spit out the volume for you, right? So if we know what that volume of the pipe is, what the flow is, we can calculate out a time. And that's what we might end up with. And once again, if it's the first time going through, you are going to have to gather this information yourself. But this might be your dedicated flushing procedure, your plan, right? You've telling people, okay, from this hydrant to this hydrant, I'm going to list some special instructions, and then this is my minimum flushing time, right? This is how long it's going to take to do those 2 pipe volumes at this location. We can make this a little bit more in depth, add more information. We'll look at this at the end here, a little bit more detailed there. But does not need to be overly complicated. Measuring that flushing effectiveness, that was part, and we had to ask ourselves how we're going to do this at the beginning. And the 2 most common are chlorine residual and turbidity. But you can use other instruments like a TDS gauge, so you can see what the total dissolved solids are and see those drop off. Whatever instruments you're using, if you're measuring pH, you can use that also. The really common ones, though, are chlorine residual and turbidity, though. So what we're trying to achieve when we're doing this flow is, sorry, this seemed to be a little out of order there, is the AWWA. They recommend, if we're just trying to remove sediment, we need to get the flow above 0.9 meters per second, or 3 feet per second within the pipe. And that is a measurement of the velocity, and that is really telling us, are we creating turbulence in the pipe? If we want to try to remove biofilm or be really effective on our flushing, we want to get the velocity over 1.5 meters per second, or 5 feet per second inside of the pipe. Now, we don't have a way to measure that, and that's where measuring the flow of water leaving our blow off or our hydrant is very important, because there's a direct correlation. We can use engineering formulas to gather that information. So if we know the size of the pipe, and this graph here showing the volume of water coming out, so what is the flow, that will directly correlate then to the velocity inside of the pipe. So once again, if we got a 4-inch pipe that we are flushing, and I want to see that I'm getting that 3 feet per second, and my diffuser, my little flow gauge on there, needs to read, at least 118 gallons per minute. If I'm over that, or if I'm reading in liters per minute, it's over 447. So let's say it's 450. Perfect, thumbs up. I'm maintaining that 3 feet per second. Now, ideally, I want to go over to the other one. I want to get it up to at least 5 feet per second, because that's going to be the most effective flush that I can do. So I need to go look at that gauge once again on my diffuser. And if it's a 4-inch pipe, well, it should be reading, over 200 gallons per minute on there. Or if a 6-inch, over 440 gallons per minute. If it's not, well, then I'm not achieving proper scouring velocities within the pipe. And I'm just going to go back a bunch of slides, but this is this gauge here, right? Might be a little bit hard to see in here, but the outside ring, that is measuring flow in gallons per minute leaving that discharge. So this one here at this hydrant that we're using, it's reading 650 gallons per minute coming out of that hydrant. So if we look at the chart, if that was a 6-inch and we're using as a 6-inch main that we are flushing, we look at the chart says, hey, I need to get at least 440 gallons per minute. I'm getting 650. Perfect. I'm happy. I'm achieving really good scouring. Now, if I'm not able to hit these goals, I might have to look at, do I need to open up the other ear on the hydrant? Do I need to flush out of both of the 2.5-inch ports at the same time to give myself a little bit more flow? If I'm going to do that, once again, and then I need a diffuser on both ends of the hydrant. They do also make diffusers that go off of the pumper port on the hydrant. So if you have that and capability to go through there, you can get more flow that way. If you are just going, let's say, out of a 2-inch blow off on the end of a line, and then you are not able to reach these velocities, these flows, then that's going back to your plan. Okay, I've got this long 6-inch main. I went to the very end of it. All I've got at the end there is a 2-inch blow off. I measured the flow out of it. I only get 300 gallons per minute out of here. So I'm not achieving that 5 feet per second. I'm not achieving optimum. Then that might be something, okay, I need to go back to the plan. I need to maybe put a plan together to put in a hydrant down here that I can get more flow, because I can go out of both ears out of the hydrant instead of the blow off, whatever it happens to be as part of your plan. So measuring those flows, and you can Google this this chart. There's all kinds of versions of this chart, or you can use this one if this helps you out with your measuring the volume that you are measuring the flow that you are discharging out of your point, and whether you are achieving proper scouring velocity in the pipe. So once again, dedicated flushing procedure, start at my source, work away all the way to the end, right? Go to this hydrant, go to that hydrant, go to that blow off, and just basically walk your system from one end to the other. Nice and easy if you do not have any looping in your system. Let's get by here. This is the problem when you have loops in your system, is that you might look at your flow coming out of your hydrant and be like, wow, I'm getting, in this picture here, I'm getting 1,200 gallons per minute coming out of this hydrant. I'm getting really good flushing. But when we have a loop, we don't really have an idea on the hydraulics of the entire loop, and where is that 1,200 gallons per minute coming from. And what you might end up seeing then is that, because of the way the flow is going around the different loops, there's no actual individual point in the loop that is achieving any type of scouring velocity. So when we have loops, this is when we need to start closing valves in the system and moving to a unidirectional flushing program. When we go that, like I said, that's a little bit more advanced than what we can cover today. But that is what you need to look at as part of your plan. So you cannot just use the flow that you're actually getting out of your discharge point, because once again, we don't know where that flow is actually coming from and how that is getting broken up inside of your system. Measuring the effectiveness, as we said, chlorine and turbidity are the most common ways to do this. If you do not have a field turbidity meter, then and lots of places still do this, a nice glass jar, paper towel works fine, right? You can see turbidity usually when it gets above about 5 NTU. So, you're going to keep flushing and filling up a jar and taking observations, and you're going to be recording your observations, right? Water still dirty, water still dirty. Well, water is nice and clear now, right? And then that's maybe when you're going to be all you can do. If you can, obviously try to get an actual instrument that can measure that turbidity. What we want to try to do is get that turbidity less than 1. That's our goal for flushing. If to achieve that, the flushing is going to go on for too long and you're going to be draining your reservoirs, then we can look at, are we going to be at least less than 5 and that is dropping? Well, in that case there, slow down your flushing, keep taking some samples, and eventually you should see that turbidity come down below 1, right? It should happen pretty quick. You know, a lot of times while you were doing the vigorous flushing, you know, you're stirring up so much material in the pipe that turbidity might not be able to get below 1 until you shut the flushing down and allow everything in the pipes to resettle. And this could occur if you have not done flushing for numerous years. You know, if you're doing it on an annual basis, hopefully those all that debris will eventually get removed from the pipe. Chlorine residuals. We want to look at what was the chlorine residual before I started flushing, what was the chlorine residual after I did my flushing, and did I see that chlorine residual rise? One of the things that is recommended that you do while you're doing your flushing is to actually increase the chlorine dosage that you are putting into your system. And this makes measuring that new chlorine residual as it moves through your system very, very easy, especially if you don't usually have very much. Like if you're, hey, I always run my system, I've got 0.2 perfect throughout the whole system. Well, while you're doing the flushing, it was recommended you go turn up the dosage so that, you know, you're putting in 0.5, 0.6, 0.8 milligrams per liter. And then that change is really, really obvious to you. Like, yes, okay, I started flushing, it's normally 0.2 here. Okay, it's still 0.2, couple more minutes, it's still 0.2. Okay, wow, I'm seeing 0.8. That should be very, very obvious. And now we can really record, yes, you know, we have clean, fresh water coming to this point. And that's information you can put out to the consumers again, saying, hey, while the flushing is happening, you're going to see a brief increase in the chlorine residual. And don't worry, after the flushing is done, you can go turn the chlorine pump back to what it normally is set at. And that chlorine residual that's out in the system will slowly fall off. Right? And so you might just have a few days, a week where it might be a little bit high to help you with the flushing. But it'll drop off very, very quickly. What you should end up with, hopefully, as we're looking at our system, you know, where our data, how we are collecting this, if we can put it in a nice little chart so we can see what data we collected out in the field, and if there's anything that's any anomalies, they should stand out very, very quickly. As I said, unidirectional flushing, a little bit more advanced, so we're not going to really cover this, but really what we're doing here then is we're just making sure those loops are cut off so that we only get flow going in one direction only. So I'm going to start to valve exercising. That is also part of the flushing, right? You are going to exercise those valves, might help you find those valves. This is an example of a pitot gauge, a type of flow gauge that you can use to measure the flow coming out of a blow-off or a hydrant. And you might only have to use this that first time to really help you measure out those minimum flushing times that you can use. And these often are built into your diffusers. I'm not going to worry about skip by there. I know that was a lot. I do have one last thing here. I'm going to just kind of go over some of the handouts that are available to you. Couple of quick things here. This is a website, Pollard Water. They are a good supplier of equipment that you might use while you're doing flushing. Or you might just want to browse through here just to see what is available. And then you can go to your parts supplier, you know, Andrew Sherritt or EMCO or whoever you are using, and at least say, hey, you know, do you have anything like this diffuser that has a flow test pitot as part of it? I want to use this in my system. For the handouts, I've got a couple here. This one here, this is the information that the City of Toronto has on their website as far as their flushing program. This is very, very in-depth. But if you are writing out your own, for your own small water system, you want to write out, why are we doing flushing? What should people expect? This is a great resource for you to, you can go to this, see what the kind of information that they are sending out to the public, and then you can incorporate that into your own information. Like I said, this is 4 pages long. They cover a lot of questions that people have as far as what's happening with flushing. And there is another one there too. This one is from Massachusetts, but it's just a fact sheet again. Once again, when you're writing out your own information you're going to have on your own website or as part of your procedure that you are sending out to the public and you're unsure of what type of information you should be sending out to the public, these make a great resource. These ones are really, really in depth. You can use this information and try to simplify it. And once again, a great resource for what the public might expect while you're doing flushing. I also gave some quick examples here. This is the type of information we hope to have in our procedures. So this one here, dedicated flushing type of procedure. So, what was the pipe size? What was the pipe length that we are trying to flush? Then this is just calculated. Right? We can use an app to calculate this information out. So, what is the volume of water in that pipe? This is how much I'm flushing from my discharge point. So this is the time that it's going to take me to do that flush. And this is the procedure, right? And so we want to have this written out. Okay, go to this flushing point. We're going to drain here. What is the recommended time? We're going to take chlorine residuals. We're going to take turbidity readings. We're going to, this is my target, and this is going to tell me when the flushing is done. And this also gives you space to put comments, put your data back, so that you can review your flushing program at the end. So that was I know it was a lot, big discharge of information to you. Hopefully some of you caught half of that, but I will open this up now to questions.
Thank you, Scott. That was a really informative presentation. Actually, I learned a lot, and I want to thank you for all that information there. We are opening up for questions right now, so you can use your chat feature to write questions, and I'll read them to Scott, and he can respond online here right now. So please use that chat feature for your questions. Scott, we do have a question that has come in, and I'm going to read it out for you. It says, we have 41 lots in one big block. Should we turn off each lot's water before flushing?
So that's a great question. In those cases, the ideal recommendation would be yes, right? And that will stop any dirty water from going out into those lots. The reality of the time and finding those shutoffs, it might not really be feasible. It might be a little bit better for you to go out and hand notices to all those lots and just tell them, between the hours of 9 and 1 o'clock on this day, we're going to be flushing. Please do not use any water. And that might be a little bit more time effective for you. If you can shut off services, especially if you've got a business in your system, you've got a little cafe or something that might really be affected by a slug of dirty water coming down their service line, then yes, you really should work with them to try and find that shut off and close it while you are flushing. So yeah, the recommendation be do it if you've got the time. If not, then just notify people that, on this day between these hours, do not use any water.
Okay, yeah, good advice there. Are there any more questions from our attendees today?
Oh, I ran so fast through there because I thought we'd have a lot of questions.
Hi, Rob. There's definitely questions in the chat. Do you see them?
I do not actually.
I see them. You see some?
See them now?
Lynn and Chris ask, is the calculating flushing time the last PowerPoint slide? Nothing came up after it, I guess.
Oh, there were more. So
Maybe
that,
so that might be a technical issue.
okay.
Jennifer asks, what about flushing the feed lines to each house? Is this necessary?
So Jennifer, that's another one that's really good for information when you are sending out to, before you're doing your flushing and you're sending them out into the community, is part of that information. You should tell people that they may see some dirty water enter their service line, and it is really good advice for them to maybe run their taps for a minute or two before they use the water for eating or drinking or anything like that, just to clear their own service line. Yes. So once again, that's something that is great information to have when you send out to people about your flushing program.
David Parker asks, is ice pigging effective or recommended at all for small systems?
Not recommended for small systems. The cost of doing that just not be effective for a small system.
Okay, he had another question. Thank you. Is it possible to effectively scour systems with smaller than 4-inch pipes? Any advice, residences?
So it is, I know my chart, I started it at 4-inch, and it's just usually we try not to, or don't see a lot less than 4 inches for some systems. Obviously, they might have some 2-inch mains that are going out there. So you can still meet those scouring velocities in those 2-inch pipes. Yeah.
That's good. Thank you. Steve asks, great information. Will you be providing a webinar specifically for superchlorination or distribution?
Okay. I can. I will talk to, and that's a great subject to do. So that is one we'll talk back internally and see if that is, if no one else is going to do that one, that is one I can do.
He put you on the spot there.
Yep.
Rob's got the chat working again, so I'll let him take over with Krista's question.
Yeah, we do have a question from Krista here. This was a refresher for me. Thank you for your time. I did get a few more tips for my record keeping. Great job. See you next time. So no question, but a compliment.
Thank you.
Any more questions from the audience here?
Yeah, there's some more coming in.
Okay, here we go. So Gary asks, if you are a micro small water system on a permanent boil water advisory, is flushing of any use?
Gary, yes, 100%. Even if you are on a permanent boil water notice, the flushing, it's not going to be the only thing that's going to get you off that permanent water notice, but the flushing on at least an annual basis, it is going to once again help with that debris that might be building up in your distribution system. And if you can meet those high scouring velocities with any biofilm that might be in your pipe, so it's not going to obviously get you off that boil water notice, but it's going to be one of the tools that you should use to try to get the best water quality in your system at all times.
All right, next question is, we have Ray here who is asking, what is a hydrant disc?
Well, Ray, great eye on the slides there. The hydrant discs, those are actually just a color indicator. I'm going to go to the site here, the hydrant disc here. Those have to do with the flow that you can get out of a fire hydrant. There is specific color codes that tell the fire department what is the maximum flow they can get out of a fire hydrant, and it just helps them with how many hoses they can hook up to that hydrant, or how much they can pull out with their pumper trucks.
Yeah, and we have a comment from Kathleen, who says that they normally send out notices to residents a few days ahead of time and asking them to also save a few jugs of water to use while the flushing is occurring.
And Kathleen, that is a great suggestion, and that is once in that information obviously you're sending out to people, that is perfect, right? So then once again, if there is any debris that does make it into their service line, that they're not affected. Yeah, that is 2 thumbs up.
I have another question here. It says, I believe our water enters the distribution system line at 60 psi. How do we achieve 200 psi?
That one, I'm not sure, Jennifer. The 200 psi is not something we're not trying to increase the pressure in the distribution system. What we're trying to do is increase the velocity of the water. And what we're also doing then is we're trying to make sure that the pressure never goes below 20 psi in our system while we are doing that flushing. So if you've got another comment on that, then that might be that. Hopefully it was just something I didn't make very clear while I was talking about that.
Right, I do have another question here. So John asks, if all connections have backflow preventers, is 20 psi uphill pressure mandatory? Sorry, is the 20 psi uphill pressure mandatory?
John, yes, it is. That 20 psi limit that we have is kind of a blanket for the entire system. Now, in your case there, if you do have backflow preventers on all those connections, yes, you are protecting yourself against that low pressure in your distribution system. But this has to do also just with the joints on the pipes that we have in your distribution system, right? When we get lower than 20 psi, we're going to maybe start sucking water through the joints in those pipes. We can start getting that some back siphonage events happening there. So yeah, throughout the whole system at all times, we want to try to maintain that 20 psi minimum.
We have a question from Kathleen with regards to, will there be a webinar regarding flushing loop systems? And Kathleen, we will definitely take a look at that for the schedule for 2026. Scott, we might be knocking on your door again there.
Yes. Perfect. And first I did skip by that one really quickly because I thought we're kind of getting up to the end here. The slides will be made available on the website. And if you look on that one for loop systems, there is a slide that kind of runs through some very, very key things you're going to look at for doing that loop system. But that is a great second presentation or another level of this one.
Yeah, I do have another question here. I take care of a small water system supplied by a private well. We have 2 INPEX lines running throughout 12 ATCO trailers, which is a count. Any tips or comments about flushing lines?
So Amanda, maybe if you can just add, do you have a blow off at the end of that, or are you trying to flush that just through the service connections going out to the individual trailers? If you've got a blow off, or a 2-inch blow off at the very end, obviously you can use that. You can still use all the information we gave. If you can measure that flow through there. If you don't, and you're just trying to go through the connections to the trailers, you're going to have to open up multiple service lines to go through the trailers at the same time to try to increase that velocity.
All right, so I do have another question that's come in here, and it says, how could seasonal flushing affect a water treatment plant? For example, we're looking into a DAF plant for our town. Would having a treatment plant reduce our need to flush? We are not the only town using the source, so untreated water would be coming to us.
Okay, in that case there, what we'd be looking at there is what you'll get after you put in that treatment plant. That's not going to alleviate you of the need to flush your system once a year. But what you're going to see eventually when you have that treatment plant is that those minimum flushing times are all you are going to need, right? You're going to be getting that really good clean water to your flushing point much quicker. So you're still going to have to do it on an annual basis, but once again, you're just going to see better results faster than someone who doesn't have a treatment plant in place.
Another question here, Michael asks, what app would you suggest for calculating flushing times?
I just quickly threw up this one here. If you just do a Google search for pipe volume calculator, there's probably about 25 of them on there right away. But here you can see, and you can do this in Imperial, you can change them over to metric. So, you know, if you have got, you know, like your Atco trailer one there we're talking about, let's say we've got 200 feet of 2-inch pipe, you can hit the calculate. And that will give us, you know, what the volume is there. So, you know, 32, you know, let's just say 33 gallons. So now I need to measure my flow, and I can see, okay, how long is it going to take me to discharge? In this case, I want to do 2 pipe volume. So how am I going to discharge, you know, 66 gallons of water out of this system?
Okay. David here has asked if manganese is controlled at the source, is a flushing program alone effective to reduce adhered manganese throughout the distribution system?
David, good question. No. So that is going to, once again, it may help you, but it is not going to solve all your problems. Especially for, in your case here, that adhered manganese that has stained the edges and sides of your pipe. In those cases, you would have to end up looking at some sort of pigging or swabbing to really scour the sides of that pipe. So the flushing, it's going to help, but that would be, once again, when we go back to the end and we look at the plan and we say, hey, was this effective? In your case, we would look at it and we would say, no, right? This was not effective. What else can we do, right? So yeah, the manganese is going to be a tough one.
Yeah. Another question here. Can you please describe how dechlorination pucks are administered during flushing, the ones that were shown in the pouch?
So in those cases, this one's a little bit hard, but you know, it does help. Let's say if you're discharging out into a ditch or just out onto a roadway that is then draining off into a sensitive area. So what you want to make sure is that the flow that you are discharging travels over the pucks that are in those pouches, so that as it travels over it, it dissolves some of the dechlorination pucks. To see if they're effective, you do need to go sample the water downstream of the pucks and make sure that the chlorine residual has been eaten up and is no longer present. So it's more of a way, so you do need some way to keep the flow directed so that they go over the entire mat. And those ones, they're maybe a little bit more simpler, but this is where we really recommend you try to get the ones that are integrated into the diffuser. It's just a better way to make sure that the entire flow is passing by that dechlorinator pucks.
David asks, can a water truck be brought in for flushing if the well cannot produce the supply needed?
Yes. So you can, once again, if it obviously if it's a potable water truck and where you're discharging that maybe into your reservoir to give you that extra volume of water. And in those cases, then you're really going to be careful on those flushing times. And that idea that, you know, hey, the calculation says I need to flush this for 5 minutes, but I only have 4 minutes of volume of water or 4 minutes available to me with the water truck. You know, that's my limitation of my plan, and just try to do the best you can in those cases.
Yeah, we have another question here. What is the immediate remediation if pressure goes below 20 psi for a non-chlorinated system?
In those cases, you know, if it is a quick little blip, you know, maybe you don't have an issue or problem. If it goes on, you know, and sorry, I'll just backtrack on that. Anytime that you have noticed that is done or happens in your system, in those cases, I would talk to your drinking water officer, explain to them, you know, what happened. You know, we were doing flushing. We noticed that the pressure at this section of our system went below 20 psi for the period that we're flushing, and follow direction from your drinking water officer, right? They will be able to come in and maybe give a better assessment on what the back siphonage risk was in that system and what procedure they would like you to follow.
Yeah. We have a question from Arvid here. It says, when closing a hydrant after flushing, is there a recommended procedure when closing the hydrant to avoid water hammer?
Nice and slow, Arvid. That's the nice and slow, right? So that is the best way to avoid the water hammer.
Okay, we're just waiting for any more questions that are coming in. Okay, so I think we've reached the end of the questions there, Scott. Scott, I want to thank you again for this really informative presentation. With the number of questions you had, the audience was very engaged and very interested. And for the audience, there was a couple recommendations for future presentations. We'll take this back to Thompson Rivers University and the All Mite Health Center and try and provide those presentations for you. And just to reiterate that if you have further questions, contact the All Mite Health Center and we'll get in touch with Scott to try and have those questions answered. Your CEU certificates will be automatically emailed to you in a day or so. Please remember to save them because we can't reissue them. And make sure you sign up for our next webinar, which is coming up on Tuesday, April 22nd, 2025 from 11 a.m. till 12:30 Pacific time. And this is on reservoir cleaning and maintenance. And I want to thank everybody very much for coming today. And we hope to talk to you in the future. Thank you.